This is a portion of the video that I took from the secondary crusher output at the demo plant. You can see the material varies a bit. It's a short video, only about 7 seconds. I'm going to rerun it and I'm going to show you how I took the sample. Ran it to a point where it looked like a reasonable representation of what I might want to sample. I take the screen snapshot, including both sides of the conveyor. Save the sample as a JPEG initially, and call it sample 1 for whatever purpose. Run it to the next level or stopping point. Determine whether that's a sample I want to take. Grab another sample. Literally the same thing. Saving it again as a JPEG, and I'll just change the sample name to 2. And I'll take a third sample. And you can take as many as you want. And I'll just take these 3. But you see, it's a heck of a lot different than going out with a shovel and a bucket to acquire the data. In the next video I'll show you how the data is processed. In this video we're going to show you the process where the samples that we took previously are going to be brought into the Split Desktop software and analyzed. And we took 3 samples. You may or may not recognize them. The first thing we need to do is set the scale. Grab the scaling button and draw across the belt. I physically measured that at 39 inches. You can see that's already set. And then I'm going to go to the scale to lock that in. And then I'm going to propagate that to all 3 of the samples, or photos. As I close them, it's going to transform the JPEGs into TIF files, which is what I need to work with in the analysis. So I will reopen them. The TIF files are all scaled. And not cascaded well, but they are. Now I'm going to crop the photographs to remove anything that I don't want to measure, particularly the empty belt. And as I do that, I'll close the original file. There's no magic to this other than you don't want to get any partial relevant rocks or the empty belt into the calculation. Alright, from here I'm going to try to make the photos easier to delineate using the equalize option. I'm going to tell it to find particles. I'm going to use no automatic finds designation. I'll do that myself. I'm going to use a 50% factor and tell it to process. And once processed, I can go in here. The size has been computed. I can make sure that my sieves match what I want and that they're in the right dimensions, and that my output saves to the right place. And as I do this, I get the gradation. And as I open the file, it shows me the results with a little bit of trimming here and get it to line up. And I'll take it like this and copy it to the Excel spreadsheet here. Which then gives me the ability to open up my AgFlow file. Do a copy, go to the adjust field data in the sample bucket, paste from Excel, confirm, accept, and we'll see how it matches the theoretical. And there you have it.